Morning, grade 7. We're at everybody's favorite lesson in the entire unit, problem solving. So, because we're not in class, I'm only going to assign you 4 questions. And if you pay careful attention to the 2 questions that I'm going to give you as an example, you should notice that the first question is the same kind of question as the first 2 ones you're going to do in your book. And the second question I'm doing is the same kind of question as the second 2 you're going to do in your book. So not the exact same question, but you can probably apply the same strategy because it's the same type of question. So pay careful attention, and then you can use these strategies to help you when you do your own problem solving. It's your choice if you want to use IDEA or not. So here's one where we're talking about ratio. So we have the teacher to student ratio at Heritage is an average of 2 to 50. So that means we have 2 teachers for every 50 students. So now we're asked the question, if there are 450 students in the elementary school, how many teachers are there? So what we're doing here is we need to look at this keyword called ratio. So remember that a ratio compares, it's not highlighting for me today. Let's see. I wanted to highlight the word ratio. Maybe my pen isn't working. Tried my finger. So we wanted to find the ratio. So what we need to do then is we need to set up a ratio as a fraction in order to solve this problem. So the first thing I know is that the ratio, I don't think my pen is working. All right, I'm going to switch to my finger, so it might be a little bit more messy. The ratio is 2 to 50. That's the current ratio. So for every 2 teachers, there's roughly 450 students. But we know that we want to find an equivalent ratio. So we want to know if there's 450 students, how many teachers are there? So I'm going to put the letter N here because that's the thing that we don't know. One thing I want to point out to you, grade 7, is this 50 represents students, which means over here, I also need my number representing students to be on the bottom. That's how equivalent ratios work. The same type of things are on the bottom, the same type of things are on the top. So we should know that if I want to solve this, I could think 50 times what is 450, and then do the same to the top, or I can solve it algebraically using cross products, which I think I'm going to do. So here's my going across. So I know that 50n equals 2 times 450. And 2 times 450, I think in my head, 2 times 45 is 90, and then I add a 0. So I get 50n equals 900. I ask myself, what's happening to n? It's being multiplied by 50. So I'm going to do the opposite. I'm going to divide. What I do to one side, I must do to the other. This cancels out. So I get n equals 900 divided by 50. Now, because I have zeros at the end, if I want, I can cancel out this 0 and this 0, and I can think, okay, what's 90 divided by 5? Well, I know 5 times 10 is 50, and then I know that 5 times 8 is 40. And 50 and 40 together equals 90, so I add 10 and 8 together, and I get 18. Again, I like to use mental math. If you want to calculate it as a long division problem, just remember number on top goes in the box. So I get n equals 18. Now I need to go back and remember, what does that n represent? Well, there were 2 teachers for every 50 students. So that means there are 18 teachers for every 450 students. That's roughly actually what we would have at Heritage if you were to actually calculate it out. So this is an example of solving a ratio question. The first 2 ones that you need to do on your own in your textbook are ratio questions. So I highly suggest that you set up your problem as a ratio in order to solve it. All right, this one's talking all about unit price. So let's pretend I went to Shoppers Drug Mart and I bought a bag of Skittles. And I bought this bag of Skittles and it was only $10. But my sister walked there the next day and she only spent $3. And she says to me, she spent less money, so she must have gotten the better deal. Now, we have to ask ourselves, do we agree with that? We want to see if my sister is correct. Did she get the better deal? And the way we're going to do that is we're going to find the unit price. So my sister thinks because she spent less money, she must have had the better deal. But I'm saying to her, no, it's really about the price you spend per gram. Because if you look at the bottom of my screen here, yes, I spent $10, but I have 1,000 grams of Skittles, and she only has 150 grams. So finding unit price means I treat each of these individually. So first what I want to do is I want to find out how much did I spend per gram. Remember, unit price, I want to have 1 as the denominator. What's the cost of one item? Or in this case, what's the cost of 1 gram? So I'm going to set up my ratio as $10 over 1,000 grams. Because remember, I'm putting the grams on the bottom because I want to know the cost of 1 gram. When we find unit price, we divide the top and the bottom by that denominator. Okay, sorry, so I'm trying to do that by my finger. So 1,000 divided by 1,000 gives us a 1 gram, which is what we're looking for. And then what you can do, if you wanted, is you can do some long division. $10 divided by 1,000. Because there's a decimal, I need to place it. And then if you take a look, 1,000 doesn't fit into 1, it doesn't fit into 10, it doesn't fit into 100, but it does fit into 1,000 one time. And then we have 0 as our remainder. So what I know so far is my red bag of Skittles, it costs me exactly 1 penny per 1 gram. 1 penny per 1 gram. So now let's do the same thing with my green bag, because I want to know how much 1 gram is. Again, grade 7, you might have questions in your textbook like, how many things can you do in 1 minute? Then you would put the minutes on the bottom. Or how much is the cost for 1 ounce? Then you would put the ounce on the bottom. So now I have $3 for 150 grams. I want to know the price of 1 gram. So I'm going to divide by 150 on the top and bottom. I get 1 gram on the bottom, right? Because now it's easy for me to compare, because I can compare the cost of 1 gram with the red bag and 1 gram of the green bag. So then I can do some long division if I want to. Number on top goes in the box. $3 divided by 150. I'm going to place that decimal. It goes in 0, and then it goes in twice. Remainder 0. So now, for this green bag, I found out that the cost for 1 gram, I guess I could put it up here too, for 1 gram is 2 cents. So was my sister correct? In fact, she was incorrect, and she actually spent double the price of me, because she spent 2 cents for every gram, and I only spent 1 cent for every gram. And this kind of shows you that often, not always, when you buy the bigger item, you get the better price. Now, it doesn't mean that you always need that many Skittles, right? This is just a hypothetical. Maybe you only want a small bag, then it's okay to spend a bit more money. But if you're going to have a party and you want to have people over, you would probably be better off to buy this big bag of Skittles as opposed to buying the smaller bag over and over again, because this big bag is cheaper. So again, when you're doing your problem solving, you can use IDEA, you don't have to, but think about how the questions that you are working on connect to the 2 questions I gave as an example. Feel free to chat with me if you get stuck. I hope you have a great Friday.